Okay, hello and welcome everyone to our NLP plus CSS tutorial series 201, trying to level up our skills. I'm Katie Keefe. I'm a postdoc at the Allen Institute for AI. And my co-organizer here will introduce himself, Ian Stewart.
Yeah, hi everybody. My name's Ian. I'm a postdoc at University of Michigan working in NLP and CSS. And really excited to see Jonathan Chang's presentation today.
Yes, and today our host is Jonathan Chang, who's a fifth-year PhD candidate in the Department of Computer Science at Cornell. He's also a data science fellow at the Cornell Center for Social Sciences. And today he'll be talking to us about conversations, specifically analyzing conversations in Python using ConvoKit. So without further ado, I'm going to turn it over to Jonathan. Ian and I will be monitoring the chat. So if you have any questions, please put them in there and we'll either help interrupt Jonathan when appropriate or try to answer them as best as we can.
All right. Thank you for the introduction, Katie, and thank you to everyone here for coming. I'm really excited to talk to you today about analyzing conversations in Python, and in particular using the ConvoKit software package to do this. And ConvoKit, I actually just want to advertise that I am one of the co-developers of ConvoKit. So I'm definitely I have a bit of bias, obviously, but I'm very excited to help get the word out about this awesome tool. So I just want to, before we begin, just quickly cover what the learning objectives for this tutorial are going to be. So I'm first going to briefly discuss why conversational data matters, right? So why is it different from just general natural language data that you might typically see in NLP, and why this distinction matters to us as computational social scientists. Then we'll talk about kind of the details of the ConvoKit package. And in particular, we're going to explain how ConvoKit really helps by representing conversational data in an easy-to-use form under a single unified model, and how it helps you express manipulations of conversational data. And one last thing to introduce is that this entire tutorial is going to be done through this interactive collaboratory notebook. I'm going to be pasting the link to access it here in the chat. And I'm doing this for two reasons. One is so that after this tutorial, if anyone ever wants to refer back to this, they'll have that, they'll be able to access it. And secondly, when I do these types of tutorials, I do like to invite people who are interested to follow along on their own, kind of play around with the code, mess around and see if changing stuff, So if you're comfortable doing that, I invite you to do so, but obviously it's not required, and I'll be running all the code on my end to show you anyway. All right, so as always in a Python package, the first step is installation. I've actually already run this now, since it does take a little while. As you can see, there's a lot of dependencies to install. The only thing I want to point out is after installing ConvoKit, there are two setup phases that need to be done to configure both spaCy and NLTK, since ConvoKit uses both of those. I'm not going to belabor that point too much, but on the official documentation, if you ever forget these steps, those are listed there. Okay, so let's begin by talking at a very high level about conversational data and why it's important to us as social scientists. So if we think about NLP, sort of broadly speaking, it's historically tended to focus on standalone text documents. So for example, news articles or blog posts, or even things like individual tweets. And obviously, this kind of data is valuable to social scientists, right? So for example, there are many studies that look at news articles to try to gauge public opinion. But a huge part of social science research also involves looking at interactions between people. And when we think about natural language, interactions usually play out in the form of conversations. Now, naively, you might think, well, I can handle conversations just by treating them like regular text documents. So for example, I could transcribe a conversation into a format like a film script, right? And that's a plain text document, and I can run typical NLP techniques on it. And that works, and it's been done. But I want to point out that that kind of treatment has disadvantages in that it obscures or kind of outright removes certain really important, unique properties of conversations. And I want to highlight three that in my mind are particularly important for social science. The first is that unlike documents, which usually involve kind of a single author or a group of closely collaborating authors, conversations involve multiple interlocutors, right? And each participant in a conversation can kind of bring in their own attitudes and sometimes have conflicting goals about what they want for this conversation. Related to this, conversations are also dynamic. That is to say that beyond just the raw text of what's said, there's also some meaningful information in how utterances relate to each other, right? So for example, the fact that one utterance is an answer to a different one, and that first one is a question, right? That matters beyond just the fact that these utterances said so-and-so words. And finally, conversations are temporal, right? So a document kind of exists at a singular moment in time, right? You just kind of read it top to bottom at any time, and it doesn't really matter in what actual order the author actually wrote each sentence. It's different for conversations, right? In conversations, it's really important to consider the order in which utterances played out, and also things like the rate at which utterances were made, right? So these are important properties of conversations that really make it worthwhile to think about creating computational techniques and models that are specific to conversations, as opposed to just applying existing NLP techniques. And just to highlight how this can be really useful, here's a small list of actual publications, prior research that have taken advantage of this unique structure of conversations to develop new and novel approaches. And I'm not going to go through each of these in detail, but I have provided the links to each paper in case you want to learn more about them. Okay, so hopefully I've convinced you that looking at conversations and treating them uniquely is important. And now I wanted to transition by talking about how ConvoKit can be really helpful for this. So there is a key difficulty right now, historically, in working with conversational data, and that is fragmentation. So first off, there has been historically a lack of any common standard for representing conversational data. And what that means is that popular data sets are often distributed in kind of these different data formats, kind of ad hoc decisions, with kind of these very task-specific schemas, right? So you never know what to expect when you're downloading a new conversational data set. And similarly, the code is also fragmented, right? Code also tends to be very ad hoc, kind of just written for the moment, for that particular project, with no guarantee of interoperability with other types of conversational methods or other code that you might want to integrate. And so this is where ConvoKit comes in. ConvoKit is designed to fill this gap by gathering various conversational data sets and methods under a single umbrella. And to achieve this, it offers two key things. The first is a unified representation of conversational data. And the second is a standardized language for describing manipulations of such data. And in this tutorial, we're going to cover each of these through interactive code examples. But before we get into the details, I want to start by foreshadowing just how useful ConvoKit can be. By showing you this, as you can see, relatively short code cell. And despite being short, this cell actually represents a complete end-to-end script, right? By which I mean you could take this code and paste it into a Python file and just run it, and you wouldn't need to do anything else. If you have ConvoKit installed, it would just run. And what this script does is it actually implements a really interesting conversational technique known as linguistic coordination. So really briefly, linguistic coordination is a measure of how much a speaker in a discussion corpus tends to either adopt the language of other speakers or, conversely, lead other speakers to adopt their own language. So kind of an intuitive example is if the US president is speaking, and this president tends to refer to the country with first-person pronouns, right? Like our country, and we need to do so-and-so. Then you can imagine that when senators address this president, even if those senators normally refer to the country in more kind of third-person terms, like America or the country, they might switch to using first-person pronouns, right? They might adopt the president's language, almost as sort of a way of deference to this kind of more senior individual. So linguistic coordination is a great example of a task that kind of inherently involves the unique structure of conversational data, right? Because it requires knowledge of both the relationships between speakers and sort of, which utterances by which speakers replied to which other ones. And as you can see in the fact that this script is so short, ConvoKit makes it really easy and really simple for us to do this really cool thing. So we actually run the script. It will take a few seconds to run, but it will be done fairly quickly after that. We're going to see a few things. So what happens is that we actually get from ConvoKit sort of a table of scores, and the scores are supposed to represent an estimate of the speaker's coordination. So positive scores mean that this person tends to get coordinated to a lot, and negative scores mean that they tend to coordinate more to other people. And so I'm demonstrating for you here is I'm picking a moderator, a very active moderator of the Stanford subreddit. And since this is a kind of authority position, we expect that this should get a relatively high score, which it does. So they get a score of about 0.06, so a relatively positive score. And I'm also demonstrating that if you just pick 5 random users from the same community, they will tend to have lower scores, right? In fact, most of them will have a score of 0, right? Which is that they don't really coordinate at all. So this example is just meant to give a quick glance at what ConvoKit can do and how it can make really complicated analyses really simple to do from a programming perspective. And so now I'm going to go into this in more detail by going through kind of each step of the process, right? And each kind of individual detail of how ConvoKit works. Before I do that, I just want to check if there's any kind of questions about the high level or conceptual questions about ConvoKit.
Yeah, we do have one question in the chat, which I'll read out. Thanks for stopping. One from Robin, who said, is responding to operationalized as immediately following utterance, or how do you encode who's responding to what previous utterance? So I think that was talking about your discussion of coordination.
Yeah, this is an excellent question. I'm actually going to talk about this in a little bit more detail when I talk about the next section, which is the kind of the data set representation in ConvoKit. But at a very high level, the information is kind of a built-in feature of ConvoKit, right? That it has this reply information, and where that information comes from kind of depends on the data set creator. So, for example, in a real-life corpus, like if I was making a corpus for congressional debates, that would probably be based on just temporal order. But in a different setting, like Twitter, for example, that would probably be based on actual like tweet retweet behavior. All right, yeah, thank you for that question. Okay, so let's begin by taking a look at the first key offering of ConvoKit, which is the data representation, right? All computational social science begins with a good data set. So in ConvoKit, we represent data sets, conversational data sets, using a class known as corpus. And so, of course, the first step in working with ConvoKit always is going to be load our data set as a corpus object. ConvoKit actually supports 2 ways of creating a corpus. The first is that we, the ConvoKit maintainers, have actually pre-prepared a lot of the most popular and most influential conversational data sets. Those are available for download from the ConvoKit website and can be accessed directly in Python using convokit.download. That's a built-in function. And the advantage of doing this is that we've already done all the work of setting these data sets up as corpus objects, and just calling convokit.download will give you a corpus object ready to use. That being said, obviously, if you're doing a bit more cutting edge research, you might have your own custom data that you've collected yourself. And so I want to point out that it's actually also possible to construct a corpus object from scratch, just kind of converting from arbitrary conversational data. However, for the sake of time, since we only have an hour here, in this tutorial, I'm going to be just loading a pre-prepared corpus from ConvoKit. Because of the fact is that creating a corpus from scratch can get kind of involved and requires a lot of ad hoc decisions. That said, if you are interested in that topic, we do have an official tutorial about creating corpus objects from scratch, and so I invite you to check that out. It is also in the form of a notebook that is kind of interactive that you can work through and can easily adapt to your own settings. But again, for the purposes of this tutorial, we're going to load a pre-made data set. And in the spirit of our hosts here, we're going to be loading the R Stanford subreddit. So this is actually part of ConvoKit's complete dump of Reddit data, which is taken from 2018. So as we can see here, we're using the convokit.download function. To download this corpus, we identify them all by unique name. In this case, it's named subreddit Stanford. It will download those files to disk, And then the corpus constructor can be used to take those files and load them into memory for ConvoKit to work with. Okay, great. So we now have our corpus, but I haven't yet explained what exactly is in this corpus. So I want to take a moment to explain the more complicated corpus class hierarchy. Besides corpus itself, there's actually 3 other classes that are kind of important to know about: conversation, utterance, and speaker. And these are meant to provide abstract representations of important concepts in conversations. And they have the following relationships. So a corpus contains one or more conversations. A conversation is made up of one or more utterances. Each utterance is attributed to exactly one speaker, right? So that's supposed to represent the person who kind of made that utterance. And of course, each speaker can own multiple utterances. They can say multiple things. And finally, each utterance can be a reply to another utterance in the same conversation. And of course, multiple utterances can reply to the same parent utterance, which kind of results in a conversation tree structure. And so that's a lot. So it's a lot easier, I think, to kind of look at this visually, right? So we're kind of looking at this representation of a corpus. As you can see, contains conversations. Inside conversations, we have utterances, and utterances have these kind of dashed lines corresponding to this idea of kind of loosely being attributed to speakers. And the solid lines here represent actual reply tos. So in the first conversation, you can see this kind of tree structure where someone asks, what's your favorite movie? And 2 different people give 2 different answers. Right, so that's kind of an example of how conversations can get complicated in terms of their branching structure. I also want to point out here that the figure kind of demonstrates that each object in this hierarchy is actually uniquely identified. You kind of see IDs for the utterances, conversations, and the speakers. So that's an attribute in each object called ID. So that's an attribute that all of these classes have. And in addition to that, the utterance class, which is kind of the lowest level in this hierarchy, also contains additional attributes to represent the actual content of the conversation. Specifically, they contain a text attribute, which is the actual words that were said in the utterance, and also a timestamp attribute, which represents when that utterance happened. And so these are meant to kind of reflect basic attributes that are common to all data sets, right? All conversations involve things being said at a particular time. Of course, most data sets will also involve some more domain-specific information, which we're going to talk about a bit later. But for now, the kind of basic attributes are ID, text, and timestamp. Okay, so let's get a little bit more concrete intuition for what this is like by unpacking this hierarchy in the context of our specific example corpus. So one basic thing that we can check is how big is this corpus? And so since the corpus is made up of 3 different kinds of objects, we answer that question by counting each object. So we provide this nice helper function, print summary stats, that does this. And we can see that R Stanford is a kind of medium-sized corpus. It contains 22,000 utterances, kind of grouped into 4,200 conversations with about 4,000 speakers, right? So in the context of Reddit, a speaker is a user, an utterance is a comment, and a conversation is a post. So now let's suppose that we want to examine individual components in more detail, right? Let's say I want a specific comment or a specific post. ConvoKit offers a number of options for kind of navigating from the high level, which is like the corpus, to lower levels like utterances. And the most basic operation for doing this is selecting a component by ID. At the corpus level, there's a set of kind of consistently named functions for selecting individual components. So you have get conversation, get utterance, and get speaker. And these all work the same way. You just give an ID, and it will return the corresponding component with the ID. So here I'm demonstrating getting a conversation, utterance, and speaker in that order according to ID, right? So here we have a post ID for conversations. We have a comment ID from Reddit for utterances, and we have usernames to identify speakers. Another thing I want to point out is that, so here I'm doing this from the level of the entire corpus, right? I'm saying get this conversation from the R Stanford corpus. But the individual classes, conversation, utterance, and speaker, also support similarly named functions. And the purpose of this is to allow you to navigate between different levels in the hierarchy. So to spell it out clearly, as shown in this flow chart, you can navigate from each utterance to both the conversation that it belongs to and to the speaker that made that utterance. If you have a speaker, you can navigate from that speaker to the utterances that they've made or any of the conversations that they've participated in. And lastly, if you have a conversation, you can navigate both to the utterances that compose it or to the speakers that participated, right? And so in more detail, we can see this just kind of, I'm demonstrating all three directions here, that there is a get utterance implementation in the speaker class, and also a get utterance implementation in the conversation class, and so on for utterances and conversations as well. And yeah, I'm not going to go through this step by step, but basically we're just seeing that the syntax-wise, it operates basically the same way. Just give it an ID, and it will retrieve that object for you. All right, so the get component functions, right, like get utterance, get speaker, or get conversation, those work really great if you already know the ID of the component that you want. But that's kind of unrealistic, right? Most often as researchers, when we're working with conversational data, we obviously don't know the IDs ahead of time. And even if we did, we probably don't have in mind like, oh, I want this specific ID. Instead, most often the case is that we want to select components based on some kind of criteria of interest. So for example, I might say like, I want to find all the utterances that mention a specific keyword, right? That's a very common thing in social science research. So ConvoKit provides methods to help with this as well. And specifically, what we provide are iterators over corpus components. So these are very similarly named to before. We have iter conversations, iter utterances, and iter speakers. And just like the ID selectors, all three of these are available at the corpus level and also at the conversation, utterance, and speaker levels using kind of the same directions of navigation that we showed before. And the purpose of these iterators basically is to implement loops over corpus components. And we can use these loops to implement these kind of filtering behaviors, right, that we described before. So I'm showing you an example of how we would actually do this in practice. So in this example, I'm going to try to find all posts on R Stanford that have at least 50 comments. And I'm going to do this by implementing two loops, one over conversations and another over utterances. So let me run this cell here. So first, I'm going to loop over all the conversations in the corpus, right? So I'm going to check each conversation, right? Like, does this conversation meet my criteria? And then in each conversation, I am then going to loop over the utterances. In this case, it's very simple, right? I just want to count the utterances. And in this example, I'm looking for, I want this conversation to have at least 50 comments. So here I just do a kind of simple if check. And I'm just kind of printing out the results. And you can see that in this case, there are two conversations on R Stanford that have 50 or more comments. Okay, are there any questions here about just the corpus hierarchy in general or accessing components?
Yeah, there was actually a high-level question. So, well, a couple questions, I guess. The first one, when you determine how, who responds to who, do you use just the ID temporal info, or can you use semantic similarity or class info to determine what's a response to what? So maybe you want to answer that first, then we'll get to the next one.
Yeah.
Cool.
So yeah, great question. Kind of similarly to earlier when I mentioned, it ultimately depends on the creator of the data set. So ConvoKit, what it provides is this concept of reply to, right? Like we have this field that you can kind of just fill in. And that's just a tool that allows you to do navigation. And as a creator of a corpus, it's, you kind of have to make this judgment of like, based on what I know about this data set, what's the most logical way to represent like replies? In the case of our example, which is R Stanford, we actually get this for free because on Reddit, there's actually a built-in notion of replies, right? Like you can actually, like when you make a comment, you can click, I want this comment to apply to this other comment. And so the Reddit API actually contains the information already. And so in this corpus, we just grab the reply structure from Reddit directly. And it's kind of similar story for things like Twitter. But again, if you're working with a data set that's maybe like from real life, right, like a transcript of a real world conversation, in that case, you would want to use something probably like things like, temporal information or semantic similarity or whatever have you. That is ultimately, we give creators the freedom to decide that. Other questions?
Yeah, someone asked about how you make a corpus from scratch or whether ConvoKit does it. I just replied that you had mentioned that other tutorial about creating a corpus, but I don't know if you want to say more about that.
Yeah, again, for the sake of time, I'm not really going to be able to go into a whole lot of detail here. But I do invite you to check out that tutorial on our official documentation. It's interactive, so it'll walk you through all the steps, starting from just, if you have raw data and, how you build it up from there.
Cool, thanks. Maybe let's keep going just so that we end up, having enough time.
Right.
Cool.
All right, so we've covered previously this idea that the objects in the corpus hierarchy have this basic set of attributes, right? Like IDs, text, and timestamp. And again, these are meant to be very generalizable, right? Which are basic to all kind of conversational data sets. But in practice, most of the time, we also have kind of specific domain information that is relevant to whatever source this data came from or to your own research. For example, in Reddit, Reddit comments don't just have text and timestamps, they also have things like scores, right? Upvotes minus downvotes. And this additional information is often extremely valuable to us as researchers. But it wouldn't make sense to say like, oh, the utterance class should directly include a score attribute because that's specific to Reddit. And so there's kind of a question of like, okay, for other corpora from other sources, what would we do with this attribute? Right? It would be empty. So how can we reconcile this dilemma? The solution in ConvoKit is the use of what we refer to as metadata attributes. So you want to think of these as extra attributes that are not directly part of each class, but are instead contained in a dict-like object called meta. And these metadata attributes can be freely assigned and modified by anyone using the corpus. And they're meant to represent, like I said, domain-specific information like scores Reddit comments, or research-specific information like intermediate outputs that were produced by code that you wrote. So in all of the pre-made corpora that we offer, there's some already provided useful metadata information. So for example, in conversations, we have things like, what was the title of the post? Or things like, did it get guild? Right, so gilding is on Reddit a way of awarding really nice, really awesome posts. For utterances, again, utterances representing comments from Reddit, we have things like the score, which I mentioned earlier, and other things like, again, gilding and stuff like when this data was retrieved. I also want to point out that this meta field is also writable, which means that you can modify existing metadata attributes and also add new ones. So I'm demonstrating this here with kind of a very simple example of taking a random utterance and adding a new metadata attribute, just kind of a joke Douglas Adams reference, to the metadata table. And just to demonstrate that it worked, if I print out .meta before the modification, we get some dictionary. And if I print it out after the modification, we see the exact same stuff plus this newly added attribute here, the answer with value 42. And so again, I kind of want to point out that adding and modifying metadata is kind of typically used as a way to store intermediate results of computations. And we're going to return to this point later on in the tutorial. And lastly, the last topic I want to cover in terms of the representational matters is that in addition to attributes, these three classes also implement some useful functions, which are used kind of to perform more complicated operations. So one useful type of operation that all the classes implement is conversion to pandas data frame objects. And this can be useful for, say, interoperability with other packages, because there's a lot of other packages in the Python data science ecosystem that kind of use pandas data frames as input. And so, syntax-wise, these are kind of similar to the accessor methods. So we have methods for utterances, speakers, and conversations. So here I'm demonstrating getting a data frame from a speaker's utterances, and here getting a data frame from a speaker's conversations. Besides this, I also want to point out that the conversation class also implements some really helpful functions for navigating the reply structure. So remember earlier we pointed out that conversations in ConvoKit have this tree-like structure, right, based on the reply to information. And we've already previously talked about iterating over conversations just kind of in linear order. But for certain kinds of research, you might actually care about the tree structure, right? You might want to navigate the utterances according to this tree structure. And we offer several ways of helping with this. First off, for visualization, we have this print conversation structure function, which does exactly what it sounds like, which is print out the structure of the reply to, print out the tree structure. So here, we're kind of seeing a kind of very simple, short conversation. I'm trying to find one that's a bit longer. This one's a bit longer. I'm pointing out here that by default, it prints the author of each utterance in its representation. You can modify this. So for example, here, I can print out the timestamp of when that occurred. And in addition to just visualizing the tree structure, you can also navigate it. So we implement a function convo.traverse, which, depending on what argument you give it, will implement one of several common tree traversal algorithms. So here I'm demonstrating breadth first search, depth first search, and both pre-order and post-order traversal. And you can see how each of those options kind of shows the output in slightly different orders. You also have the option of unpacking the tree structure into linear reply chains. In other words, root to leaf paths. And that's really useful if you're trying to use algorithms that, for whatever reason, can't handle tree structure, right? And expect something more like a linked list. And so you can do that as well. In the example that we have here, we sort of have two we have two leaves and therefore two linear root to leaf paths. And lastly, sometimes what you care about is not so much the actual tree structure, but simply the chronological order, right? Like sometimes you just want to throw away the reply to information, just say, okay, in what order did things happen? And we have functionality for that too, in the form of a function called get chronological utterance list. And that's fairly simple. It will just iterate linearly through the utterances in temporal order. Okay, so that concludes our discussion of the basic data structure of ConvoKit. And so I want to pause here if there's any questions about anything we've talked about so far.
Yeah, Jonathan, we have a quick question about does ConvoKit work for non-English data as well?
Excellent question. So yes, so ConvoKit supports Unicode functionality, for its text. So in principle, you can put in you can input text from any language you want, and you have no problem in terms of the representation. In fact, we actually do have most of our data sets, our built-in data sets are in English, but we actually do have a small subset of the Chinese Wikipedia talk page discussions as a ConvoKit corpus available. So that's kind of an example of other languages in ConvoKit in action. The one caveat I want to mention is that in the next section, we're going to be talking about algorithms, right? Basically like running conversational methods and models. And a lot of these models are kind of trained on English. So even if you have a corpus in non-English language, it does not necessarily guarantee that you'll be able to run all of the built-in algorithms that, that ConvoKit offers. Simply because if there's a model that was trained on English, it will not transfer directly to other languages. So that's the only caveat. But yes, great question.
Another question just popped up. So it looks like they're asking, can you provide statistics or a summary for each speaker or utterance, or any more analysis and conversation such as topics, etc.? I think you're going to answer the next question later, but maybe you can answer the first question now about summary.
Yeah, so we're gonna in a moment talk about doing more interesting things with conversations. Just to briefly mention, if you want to summarize information about a speaker, at least when I use ConvoKit, I think the best way of doing that is basically through the data frame representations. Right, so once you've converted a speaker, say, into a data frame of its utterances, you can very quickly compute things like, how many utterances did they participate in, when were they active by looking at the timestamps, kind of just using regular pandas methodology. But sort of the advantage of us offering interoperability is that you can kind of plug in functions from the outside ecosystem, similar to how when you use things like scikit-learn, you often use it in conjunction with things like NumPy, SciPy, and other packages like that. Yes, great questions. Thank you. Okay, so far we've looked at how ConvoKit standardizes the representation of conversational data. And so next we're going to examine the second key contribution of ConvoKit, which is not just representing the conversational data, but also expressing how to manipulate it. And just as a heads up, the first code cell in this section is going to take a few minutes to run. So I'm actually going to get that started right now and then talk. And by the time I'm done talking, that cell should be done running. Okay, so let's talk about manipulating conversational data. In ConvoKit, manipulations of conversational data are expressed using the transformer abstract class interface. That's a lot of fancy words, but at a high level, a transformer is an object that takes in a corpus and then returns or outputs the same corpus, but with some modifications done to it, almost always in the form of changed or added metadata, as we discussed previously. So just kind of a simple flow chart, have a corpus, feed it to the transformer, get modified corpus. Whenever I present this, I like to use an analogy to language. So if corpus objects you can think of as the nouns of ConvoKit, then transformers are the verbs, right? They express things that you can do. And just like in the case of natural language, even if an individual transformer seems simple, combining various corpus and transformer objects, much like constructing a long sentence out of individual words, can allow you to express surprisingly complex analyses. Now, before I go into that in any detail, I do want to have a brief aside to mention that the name transformer has no relation to the increasingly popular neural network architecture called transformer. Actually, the name is borrowed from a different source. It's actually borrowed from scikit-learn. So those of you who have used scikit-learn might know that scikit-learn has a thing called a transformer, which is kind of like their base model for just representing abstractly any machine learning model. And ConvoKit transformers are actually directly inspired by this. In fact, the ConvoKit transformer class specification covers a very similar set of functions to the ones from scikit-learn. So you have fit and transform, which respectively represents training or fitting the transformer model, and then actually using the trained model to apply whatever changes to corpus it will do, right? Apply any modifications. And again, those are named identically to how they're named in scikit-learn. The only place where our kind of syntax differs is that we add on an additional function in this set, which is transformer.summarize. This is an optional function, which means that not all transformers implement it. But it's really useful for kind of the more advanced or more complex models, because what it does is generate a human readable summary of what the transformer has done. So for example, if you have a transformer that extracts a bunch of conversational features, it might implement a summarize function that presents a count of all the features that it extracted. And we include this as a new function on top of like the kind of standard scikit-learn hierarchy, because of the fact that conversational data is often so complex and kind of needs a little bit of simplification for us as humans to get intuition for what's happening. Now, implementation-wise, transformer is what's known as an abstract class, which means that it's not meant to be used directly, but instead simply defines sort of a common set of methods, right? Specifically this fit, transform, and summarize. And then the way that you use it is that for every individual analysis method that you want to use or implement, you implement them as subclasses of transformer. Now, so those of you who are not familiar with how interfaces and subclasses work in Python, I don't want you to worry too much about this. For our high-level purposes, all you need to know is that each manipulation of a corpus is represented as its own individual class. But all of these classes all look the same in that they all have this common set of 3 functions. And so it really helps to see an example in action. So that's this cell that just finished running. So this example shows a very common first step that we often do to conversational data, which is parsing the utterances to obtain things like dependency trees and part-of-speech tags. In ConvoKit, we have a transformer subclass called text parser, which implements this behavior using spacing. And basically, just the main thing I want to show here is that we create this parser object, and we just call parser.transform on the R-Cepheid corpus. And this one line of code is all you need to tell this object, hey, apply this modification to all of the utterances in this corpus. We mentioned earlier that transformers modify the corpus by adding or modifying metadata attributes. In this case, what text parser did is it added a new attribute called parsed. And so I'm showing here, looking up that attribute to confirm that it works. And again, this is a bit messy. I'm not going to go through this in much detail, but we're getting kind of a representation of the parse tree, as well as things like parts of speech. Right. So for example, we have these dependency tags and so on. So that's an example of a transformer in action. But you might be thinking, hey, wait a second, this doesn't look very conversational, right? All we did here was we just ran spacey over a bunch of utterances, which is just kind of this classical non-conversational NLP technique. And you're right, that's true. But that's just because text parser is meant to serve as only the first step in a larger analysis. And this is a really important thing to note about transformers. Because they store their results in the corpus itself in the form of metadata, multiple transformers can actually build upon each other by having one transformer act on the output of a previous transformer. And in fact, stacking transformers in this way is exactly how we tend to construct complex analyses out of simpler transformers. Again, I want to remind you of this whole verbs and sentences analogy. So just to give you a visual example, this is kind of showing a pipeline of stacking different transformers. So you might start by parsing, and I'm using color coding to represent different steps, like different steps of the corpus after each transformation. So after you parse, you get this green corpus, which has the dependency parse information in the metadata. And you can then take that green corpus and feed it into another transformer, like extracting politeness strategies. And you get out this red corpus, which contains the extracted features. And then you can go even further and feed that red corpus into another transformer, like let's say a classifier transformer, which can be used to do something like get prediction scores. So this is kind of an illustration of how, even though each step is kind of simple, we chain them together to build up this pipeline of a relatively complicated analysis. As we can see kind of in the labels of each step, we tend to group transformers based on how early in the research workflow they tend to appear, right? So in the earliest step, we have what's known as pre-processing. So these are things like simple text cleaning or parsing. Kind of more in the middle, we have feature extraction, right? So these are, things like, getting politeness strategies, right? Or, other kinds of transforming basically plain text into kind of more numerical features that can be used for future models. And at the highest level, we have analysis, right? So these are implementations of kind of conversation-centric models from the latest cutting-edge research, which may possibly rely on features that were previously extracted by a feature extraction transformer. And so again, this is the kind of thing that makes a lot more sense through examples. So what we're going to look at is 2 examples of how transformers can be used to obtain kind of interesting, uniquely conversational findings. So the first is an example of a feature extraction transformer, and the second is an example of an analysis transformer. And these are both going to be implementing methods from the literature that kind of take advantage of the unique structure of conversational data. Yeah, so these two examples will be our last section that we cover in this tutorial. So before I get there, I want to make sure, are there any conceptual questions so far? All right, sounds good. Okay, so let's take a look at these examples individually. And again, hopefully this will illuminate further what this process actually looks like. So first I want to cover briefly a feature extraction example of prompt types. So this is an implementation of a model known as question typology from this paper, Asking Too Much. And what this method does is it learns categories of questions that exist inside a data set. And the unique thing about this method is that it's completely unsupervised. No manual annotation involved. The way it does this is by characterizing questions in terms of what kinds of replies they tend to get. So ConvoKit implements this methodology using this class known as prompt type wrapper. And what I'm demonstrating here, again, just to repeat, prompt type wrapper is a transformer, which means that if you want to use it and apply it to the R Stanford corpus, all you need to do is instantiate it, call fit. So remember, this will do the training step. In this case, kind of learning the types of questions. And finally, you can call transform to sort of apply what was learned to the whole corpus. In this case, taking the learned features and extracting features from each utterance. So let's say that as humans, we want to know exactly what this transformer computed. Remember that earlier I mentioned that the summarize method is designed to give kind of a human readable summary, hence the name, of what a transformer did. And most feature extraction and analysis transformers will give you implementations of the summarize method, again, for the sake of human interpretation. In the case of prompt types, the summarize method prints a detailed explanation of each type of question that it learned. And it's going to show you both what kind of language is associated with this question type, and it'll also print out some examples of questions that got classified as that type. So let's say that I call the summarize method. And again, I'm going to give it the R Stanford corpus. So I'm going to say when you pull examples, pull them from this corpus, which we previously already transformed. And so I just want to walk you very briefly through the output here. I'm not going to go into a whole lot of detail because, again, the point of this exercise is to just demonstrate kind of the code that is used to get this and not sort of go deeply into this actual method. But I just want to just show that it's actually, even though the original paper didn't use the R Stanford corpus, we were able to apply this code directly to this data, in ConvoKit, and get out kind of very sane results. So here we're showing one type of question, and it's showing that the type of language associated with this type are phrases like "what is," or "what do I have to," or "what do I have to do," and so on. So this looks like kind of factual questions of like, asking like, what is, like, do I? And we can verify this by looking at the examples that it pulls. So for example, this person's asking, what network carrier is best for the Stanford campus? Right? This person is, what is your intended major? Right? So you can see that these are all sort of like factual, like what is, how is questions. We get another type here. And here we see language like, does blank have? Or do blank think? And so these are more sort of like opinion-y questions. Right? So here, this person's asking, will this be a good entryway to grad school or a career? Do I fit with the school's culture? Right? So those are kind of good examples of more opinion style questions, and so on. Again, I'm not going to cover every single learned type, but you can kind of see just by looking at the summary that we do in fact seem to be getting kind of the same human interpretable classification of questions. And again, this is all done in an unsupervised way. And so lastly, I want to turn to an analysis example. And this is actually going to return to the opening example of linguistic coordination. So now that we're armed with the knowledge that we've covered, we're finally able to understand exactly what that example script was doing. It took a corpus, the exact same R server corpus that we've been looking at so far throughout this tutorial, and it computed coordination scores using a transformer, specifically the transformer called coordination. And this transformer actually implements a computational model for coordination that was proposed in the 2013 Echoes of Power paper. And so I want to just bring us back to the relevant lines from that script, which were running the transformation. So that was creating a coordination transformer, calling fit to learn the coordination scores, and calling transform to compute coordination for each speaker. And again, my point here is that this is obviously a very different, computationally speaking, a very different model from the prompt types. And yet, syntax-wise, we had the exact same 3 lines of code. Right, so this is demonstrating to you how ConvoKit takes like this very disparate field of very different computational methods and unifies them all into a very consistent way of a very consistent set of syntax, which means that even if you're unfamiliar with like specifically coordination, as long as you've used ConvoKit before, you already know how to use this coordination transformer. And that's a really useful property for very quickly exploring and playing with conversational data. Another thing I want to point out is that we can also now finally understand how the example script was retrieving the scores at the end. It was specifically using the summarize method, just as before. And in the case of coordination, we can see that the summarize method is actually producing a full speaker level lookup table of coordination scores. So in the example script, we only looked up scores by individual speakers, but we can actually do stuff like ranking speakers based on their coordination scores. And so we can examine the difference between people here at the top with relatively high coordination scores and people down at the bottom who have scores of 0 or, scroll all the way down, even a handful who have negative scores, which means that they don't tend to get coordinated too, but instead they tend to coordinate to others. All right, so hopefully this has shown you sort of the power of ConvoKit, right? Using multiple disparate, very different kinds of computational models under a unified, very short and simple syntax-wise set of commands. I just want to conclude by saying that, obviously in this 1-hour tutorial, we could only scratch the surface of all that ConvoKit offers. We looked at sort of like 3 specific transformers, but there's actually a whole family of different computational methods that are all already implemented for you in ConvoKit. And if you're interested in learning more, I'd like to invite you to read the official documentation, which sort of covers everything we've talked about here today, as well as sort of introducing, here are all the different data sets and transformers that you can use. And I'd also like to remind you that ConvoKit is open source. And so if you're especially interested here, we invite any and all contributions. Not only in terms of code contributions, but also just things like, asking questions or contributing data sets, or even requesting new features, right? Any idea you have for making ConvoKit better and more useful to you, we would love to hear it. And with that, I just want to open the floor to questions.
Yeah, thanks. We did have a side question from Fazel, which was, can this be applied to live conversation?
That's a great question. We've actually gotten this question in the past. The answer right now, as of the current release, is no. And the reason the answer right now is no is that the current implementation of ConvoKit requires sort of like this kind of very fixed representation of data that's kind of saved in this JSON format on disk, which is a little bit slow in terms of reading and writing. So in the current moment, it's difficult to apply to live conversations because there will be performance issues if you try to do that. But the good news is I'll give you a little bit behind the scenes. No one else knows this yet, right? But behind the scenes, we are actually currently actively working on implementing an alternative optional backend for ConvoKit, which uses actually a database structure. And so that's actually designed to be used exactly for the use case you're describing for live conversations. So that's currently being worked on. It's not out yet. There is actually if you go to our GitHub, the development is happening on a separate branch. And if you're kind of comfortable with kind of installing Python packages from source, if you want, you can actually install that branch and try it out. but it's not yet in an official release. But it will be soon, hopefully.
We have another question. Could it be applied, meaning could ConvoKit be applied on text from peer review, such as open peer review?
Also an excellent question. I think the answer there is that you can apply ConvoKit to any text you want. The caveat, of course, is that you have to have both a way to access the text, which I guess in the case of open review you would, because it's open. And also you ultimately do have to convert the text into the corpus format. And again, I didn't have time to cover that conversion process here because, again, it gets a bit involved. But I will once again repeat that we do have an official interactive tutorial about that. And so for those of you interested, I invite you to check that out.
Do you think you would see like coordination in peer review? Just like, I don't know, based on your understanding?
It's a great question. I think if anyone could, if anyone could collect that data and, try it, I would love to hear the results. I honestly, from my perspective, I don't know what to expect. Because on the one hand, clearly there is, seniority, among academics. At the same time, peer review is anonymous, right? So it's not clear, to what extent, if you don't know that this other person is a senior in the field, to what extent, you would coordinate. Maybe it comes across naturally from their language, who knows? And that would lead you to coordinate. I think it's a great question. And I think the fact that ConvoKit makes it kind of like straightforward to try it, is kind of makes it, really appealing to just try it out and see what happens.
Cool, thanks. We're at time, so I'll just repeat that, please fill out our post-tutorial survey just to try to help us make future tutorials better. And then Katie, do you want to lead us out?
Yeah, I just want to say thank you so much, Jonathan. Please do send him an email or contact him on GitHub if you have additional questions, or those of you watching on YouTube afterwards. Please do be in touch, as well as Ian and myself are always open to emails on suggestions or ways that we can improve this tutorial series. And then finally, our next tutorial will be on March 16th. That's about pre-processing social media text, hosted by Steve Wilson. So please do put that on your calendar and join us then. Thanks again.